Hey there, fellow members of the concrete construction industry. Before we get started today, I want to take a moment to address something important. As professionals in this industry, we understand the challenges we face and the constant need for up-to-date knowledge and valuable insights. That's why we're here, providing you with a podcast that caters specifically to our community. But let's be real. Producing the show requires a significant investment of time, effort, and resources, and that's where we need your support. We're embracing the value for value model, which means we're reaching out to you, our dedicated listeners, to help us sustain and enhance the podcast. Think about the value you gain from our episodes, the practical tips, the industry trends, and the expert interviews. We want to keep delivering that value to you, but we can't do it alone. Instead of interrupting your listening experience with ads or sponsorships, we're relying on your generosity. If you find value in what we do, we kindly ask you to contribute what you can. Your support helps us continue producing high-quality episodes that address the specific challenges and interests of our concrete construction community, from supporting the cost of equipment and hosting fees to bringing in industry experts for exclusive interviews. Your contribution makes it all possible. We understand that every business and individual has different capacities to give, and no amount is too small. Whether it's a one-time donation or a recurring contribution, we appreciate your commitment. By supporting us, you become an essential part of our mission to provide valuable content tailored to our industry's needs. Together, we can elevate our professional knowledge and expertise. So please take a moment to visit our website, concretelogicpodcast.com, where you'll find a donation page that makes supporting us quick and easy. Thank you for being an integral part of our concrete construction community. With your support, we'll continue to build a brighter future for our industry. What is the most used man-made material on Earth? You guessed right. It's concrete. Look around. It's everywhere. Sidewalks, driveways, foundations, floors you stand on, and even entire buildings are made out of concrete. So why don't we discuss it more? In each episode of Concrete Logic, we will explore one concrete-related topic with the help from industry professionals that are shaping the future of the trade. We'll talk with suppliers, contractors, architects, engineers, specialists, and even some proponents of competing materials about their views of concrete and their vision of its future. And welcome to another episode of the Concrete Logic Podcast. And today I have Joseph King with me. Joseph, you got quite a unique background here. You're currently managing partner at Golden Bear. You're a director at the Department of Energy, and yet you spent some time at DuPont. So what else do you want to tell us about yourself, Joe?
Well, I started out actually at GE after I got my PhD and did a postdoc in Germany. Was there for a long time. I spent 7 years in the insurance industry doing risk management, then got back into science and at DuPont and ran their global construction group for technology.
Cool. But today we want to, what you're willing to share with us today is your time over at Department of Energy. We thought it might be interesting to talk about when folks apply for grants and different projects out there that maybe whatever you can share of the programs that you were a part of. So if you want to get us started on how that all works, I find it interesting.
No, it's not top secret for the Department of Energy. I work for the smallest department within the Department of Energy, but we're often used as reviewers for contracts and grants outside our own department. I was in the Advanced Research Projects Agency for Energy, and it was modeled after DARPA. How do we do next generation white space in the energy development? And one of my areas especially was cements and concretes. So I set up a cement and concrete program. Now, the way ARPA-E works is we're short term, 3 years with renewable contracts, but usually 3 years. And then we get a lot of academic people. They have to go back to their institutes after that. If you're an outside person coming from industry, then you have to go out and find a real job again. And so the net effect is they liked me enough that I stayed 7 years. So I had a lot of fun. But how it works is we look for a white space that isn't being addressed in any kind of area where there's major greenhouse gas production or energy consumption. And so for me, that was cements and concretes. And as you may know, the embodied energy in greenhouse gas production per kilogram for concrete is among the lowest, or is the lowest, of any material that man tends to use. So it's a real challenge. So my challenge to the community was, how do we increase the durability 2 to 3x while lowering the embodied energy in greenhouse gas production? So pretty big challenge. And this is before it got voguish. This was back in 2015, 2016 it started. Anyway, we'll put out that challenge. We'll do a request for information. We'll send it out to about 1,700 universities and businesses and national labs to get input on what topics we should look at. Then I'll skinny that down, hold a workshop, and invite 80 to 90 experts in the area to come. And we'll spend the day and a half quibbling over what are the things that should be funded and what are the things we shouldn't fund. And then I'll skinny that list down, present an internal presentation that lasts 2 hours to the ARPA-E community. And there are only 18 of us at the time. There are only 18 of us program directors. And a program director is a federal employee that controls the funds that go out to fund the people. Now, after I get approval to do that, it has to go to the Senate. So whatever amount of money I think we're going to do, the Senate has to approve that. But it's a non-object, which means they have 3 days to say, yeah, we like it, or no, we don't like it. So we're not captive to some of the systems. The founders of this, Arun Manjapur, who set this up, realized that we couldn't be held captive to how Congress works. Slow. Anyway, so he was a pretty brilliant guy. When we do this, we actually usually have what are known as contractual agreements. They aren't grants. We do have grants. Those tend to be smaller amounts of money, like $500,000. And a grant is something that when it's given out, we have no control over the output.
Oh.
So academics and people like grants because they can or can't do what they claim they were going to do.
Right.
Okay.
They get to play more than.
Right. They have a lot more latitude to do it. So in a contractual agreement, if you're not following what we negotiated you're going to deliver, and we'll put in some go, no-go points throughout it, they're usually 3-year contracts, then we can cancel your project in 30 to 60 days.
Oh, wow.
Completely. And then I'll take, because the money is already predefined by the Senate and approved by the Senate, we can't add new members, but we can reallocate that money among the remaining members. So we can actually, it's called a plus up. We can actually give them more money.
Oh, so so is there checkpoints for them when you do a grant? You say there you have this deliverable by this date, and if you don't get any more money. Kind of like building a house, right?
Well, we're more engaged than that.
Oh, okay.
Okay, we want all of our children to grow up and be successful, right?
Yep. So
we do quarterly reviews, usually face-to-face, particularly when we're starting out. And that really helps, with the discussion. The teams like it a lot better. They get to know you. But it causes a lot of travel for the directors. And so the principal investigator and the program director are the only ones that are technically supposed to meet face-to-face. But if I'm going to, say, UCLA or MIT, the whole team will probably be at MIT, okay? And I'll have 1 or 2 technical support people that work with me too. Now, one of the things that happened early on is they realized that some of their programs started out as, 2 guys in a garage, and at the end of 3 years, it was still 2 guys in a garage. So they added something called the Tech to Market group into ARPA-E, and this was a couple years after it started. And ARPA-E is one of the newest organizations. It's only about 14, 15 years old.
Yeah, and if we didn't say it, ARPA-E is Advanced Research Projects Agency, right?
Right. I said that once, but
Oh, sorry.
I didn't tell them that that's the acronym.
Yeah,
So
okay.
I apologize for that.
Yeah.
Anyway, and what they do is they help the team structure a business program. We don't fund science for the sake of science. So NSF does that. Sometimes NIH does that. But we want something that is scalable, buildable, commercializable. And if you're not going to use it, it should be socializable among the community too, because we're picking the best brains from the entire community to solve these problems. And if we're going to fund your project to do one of those, then we want there to be a benefit for the community. These are American taxpayer dollars that we're throwing around. So
Yeah.
we want to make sure there's something coming out of that. So that commercializability and scalability is a huge part of how we make our assessments. Now, we'll come every quarter. My first year, I think I did a little over 150,000 miles flying domestically.
Whoa.
Not counting all the driving. But you get to know the teams. You can see what's working and what isn't. And you can help them with getting contacts. And if they don't know how to do something, or they're great chemical engineers, but they haven't done any of the marketing stuff, the marketing guys will help them figure out how to build a business plan and put that together, how to do a cost benefits analysis, how to do a technical economic analysis of the cost, first where you are versus at scale, if you can scale it, and get connected to groups that might be able to help them think about how to run a business.
Huh.
So there's a lot of value we bring. We're a little scary because we are feds.
Uh-huh.
And, here we're the government. We're here to help is a scary phrase, but that's not how ARPA-E works. Our goal is to make you successful. But if there's some physical reason, some physics, engineering, thermodynamic reason that was not apparent at the beginning of the project, so it can't be done, we'll try to work with you to pivot it into something successful. And if that can't be done, then we'll have to cancel it. And we tell them all that up front when we do our negotiations. So we work out a timeline. We work out a staged deliverable for each of those timelines. And one of those staged deliverables will be a go, no-go point. So if they can't hit that, then, game over kind of.
Right.
So it's important. But the other thing we look for in the teams is it a balanced team? It's one thing to have an idea that you can reduce to practice on a bench, but can you scale and execute it? Have you thought through that? Are there members of the team so that it's not just, two great material scientists coming up with the next generation cement? Do they understand the fabrication, the scale, the production of it, and how would you commercialize it? All those stages have to be built in every single program, or we don't fund you, even if it's a great idea.
Yeah, you gotta have a business plan.
Right, and it's amazing how many professors are really good about thinking of ideas, but not so good on the business plan execution side.
Yeah, they're academics. They haven't worked out in the commercial private world, so they haven't ran a business before.
Yeah,
I assume, but
no,
they're good at thinking though.
Yeah, but that's not enough in our book.
Right.
I mean, that's more NSF than it is us.
Yeah.
And NSF brings a lot of value because some of those are a prelude to us. And some of our programs, for example, we actually do stuff in the nuclear area. We have a 3 or 4 excellent fission fusion people. And those then sometimes go into the nuclear part of the Department of Energy as a follow-on. So some of the advanced manufacturing organization, which is also in the Department of Energy, they will sometimes pick up some of our stuff too. So I mean, we're trying to get them past the valley of death, but we fund all sizes of groups. We're a third large corporation, a third academic, and a third national lab and small business and startups. So That's how our money gets allocated, not by design, but by fact. If GE comes to me with a great idea and has a great proposal, we'll fund GE. If, a small startup that's a spin out of VCU, and it's a great idea and they have the team put together, we fund them. So
Wow.
it's
Like Silicon Valley of the government.
well, yeah, we try to be. And for all the different areas, like I said, we span everything from marine crop production to nuclear to cement and concrete.
Mm-hmm.
Of course, I do have to mention that since this is a concrete show,
we try to be, at least.
when I was creating the durable concrete program, my boss came to me and said, "Joe, how do I know your advanced gray lump of cement is different than the old gray lump of cement?"
Mm-hmm.
And I said, "Well, if they use it and it is more durable, does that pothole show up every 3 years instead of every year?"
Mm-hmm.
There are durability things, and I think this is where transportation plays a big role, because building a bridge decking or a highway component, the abuse that it sees per unit time is great enough that for me was the regime that I like to see for advanced accelerated testing. You
Yeah.
know, people talk about lab stuff. No, I want it out in the real world.
Yeah. It's refreshing to hear that there's agencies in the government out there that think long term instead of short term. If this program sounds like you're concentrating on the durability of concrete, so we didn't have to go out there and replace it and repair it year after year after year. Because when I hear the government, I hear we need to spend more money. We just raised the debt ceiling again, so we're always looking to spend more money. So it's refreshing that there are parts of the government that are looking to refrain from that.
Well, if you're familiar with the business world, you realize that the people building it and the people that have the O&M or operation and management and repair side of it are not the same. So if you put up a structure and say its day one cost is $1 million, well, the operation and management over that 30, 50-year lifetime is going to be 6 to 10x of that in terms of repair and what you do. So you want to mitigate both sides. I want to mitigate the greenhouse gas and embodied energy, but I want to improve the durability simultaneously so the actual owner benefits from what they invest in.
Right. Huh. So, and your specialty was in concrete and cement when you were there?
Well, it was materials. I did that, and I also did grid space.
Okay.
And what happens is, because the program directors time out, sometimes there'll be a residual program, and I inherited one for natural gas.
Oh, cool.
And it was called Monitor. And if you go to the ARPA-E site in the Department of Energy, you can see all of our programs and who's assigned to them. And what it was is, how do you detect, locate, and quantify natural gas leaks? And so that was the intent of that. One of the things I did learn, and this is how our prelude discussion about leaking gas wells, I spent a lot of time with the drillers and guys that change the casings and all that kind of stuff. So I got a pretty good view of how difficult it is for the gas industry to manage, particularly orphan and abandoned wells. Mm. And those end up being problems of the state or the federal government, just because until the 1950s, they didn't even track orphan and abandoned wells. Mm. So, and then a lot of them post that have been cut down, what they say, cut below the plow line, so that people can use the fields again. So they might not even know there are abandoned wells underneath their field.
That's not good.
No, well, it's a surprise depending on what happens. But
yeah, huh. So can you talk a little bit about maybe some of the projects you ran across or were fans of?
Yeah, one of the ones that since rebar is one of the main or the main degradation mode for a lot of structures. And you see its degradation. It basically expands a factor of 3 and crushes the cement from the inside, or concrete from the inside. I invested in a group in the Upper Peninsula that made basaltic rebar. And Owens Corning actually started out making basaltic materials, but they found that sand was more consistent than basalts, the natural rocks. And I think when you were talking to the Alamo guy, he mentioned about how his limestone might be different than North Carolina limestone, different than Montana's limestone. And he's absolutely right. And so the inconsistency in the basalts, you need certain qualities of it. And this one group, Navocus, had come across that and done a great job, but they needed to fix the bushing on their strander. The bushing is the plate that has all the little holes that things strand through.
And where do the basalts come from?
Basalt is an igneous rock that's basically the majority rock on Earth's crust.
Oh, okay.
So
there's lots of it then.
There is a lot of it, and it's very cheap.
Yeah.
And you can see it everywhere. Like the Devil's Tower in Wyoming is
cool.
a basalt.
Yeah.
Or the Giant's Causeway, and then you get these giant hexagonal pillars that are just, the way it cools. So you see that. You can see some of those in the United States. The Columbia Gorge is basically a basalt wall. So you can find it everywhere, or you can mine it. And so he was doing that. He also makes e-glass strands too. And the reason we funded that is I was hoping that he could get around the degradation problems that you have when you carbonate over time the rebar, and it degrades. And he's still developing that, but he was working a little bit. Owens Corning kept coming to them, and now Owens Corning comes out with their pink bar, and it's basically getting away from steel rebar and some of the problems that you have with that. Plus, it's got a huge weight advantage, and it's compatible with the cement environment.
What are the limitations of it, though, compared to steel? Are there, if there are any?
I haven't followed that as much because there's not enough of it out in the field to say, oh, this bridge structure fell down because they used it, or this highway wasn't expansive enough. It tends to be slightly more ductile and flex. You can flex it a lot more. And some of those problems could degrade it over time, depending on how brittle a material is around it. So, but I don't think there's enough long-term data on a statistically large enough sample set to say at this point. Everything looks good now.
Yeah.
But we need more data to say. And I think a lot of the demonstration projects that are going on right now, some are 10 years old, but that's still in its infancy if it's a cement concrete structure.
Yeah, exactly. Yeah. Well, that's the intent, at least.
Yeah, no, the intent is, is there an alternative to steel? Even steel production is a huge greenhouse gas producer. And not that you don't use a lot of energy to make glass fiber, but the glass rebar might also mitigate our demand for steel as well. So that would be quite an advantage of it if it can be generally used.
Yeah. Not to put you off track here, but you mentioned something that caught my ear was the use of energy, more energy using, like you're saying, steel uses a lot of energy to produce. Is the intent, since you've worked for DOE, is the intent for us to use less energy to offset the greenhouse gases, or are we looking at different ways to maybe, I don't know, lack of better words, filter that stuff out so it doesn't get out in the atmosphere and impact us?
Well, it's a combination of things, because the energy footprint of a material is a compilation of things. And if you do an accurate life cycle assessment for, say, concrete, it really starts at the mine, because you got to mine it, you got to transport it, you got to grind it, You got to send it through the kiln, and then you got clinker. You got to grind it again
Yeah.
and blend it. So, and then you got to bag it, and then it's got to go to wherever it's got to go. So, the energy, even for the transportation and the mining, is part of the legacy energy footprint. So, can you shorten or eliminate some of those things? And so, it's not just greenhouse gas production. 60%, roughly 60% of the gas CO2 comes from the actual kiln, the first stage of the kiln, when you take limestone and it makes lime, right? CO2 coming off.
Yep.
But then about 17% of the energy is from the fuel that burns and heats the first section of the kiln. And then about another 17% that does the second stage, where you're making the A-light, B-light, and the other components that ultimately coagulate into clinker. So, can you mitigate some of that footprint? And so a lot of the people focus on the CO2 production from limestone. So they come up with, 1L and LC3 and some of these other things that use clays. You don't get around the fuel component, other than you lose the second part of the kiln, 17% for the fuel, and the CO2 production from the limestone.
Mm-hmm.
Okay, but it's still a 50 mix. LC3 is still a 50% mix of OPC itself, and 1L is a 90% mix of OPC. So there's still a lot there, but less.
Mm-hmm.
So the question comes back then, does it have the durability and the performance characteristics that the people need in the field?
Right.
And, LC3 has been around for quite a while, 2 decades, mainly in Europe. But, 1L, I think it's worked its way in here and there, but it still scares people from what I can tell.
Yeah, it's a new thing that we're all getting used to, but we've said it before on the podcast that we've gone through like SCMs and things in the past that we weren't used to, and somehow got past that. And that was that maybe 2010, 11, 12, I guess, was when those really came on. But we finally got used to that, and now the cement industry decided to change things up on us again. So we're all we don't know what to do. It's again, like you mentioned before, previous guests, really depends where you are in the country and things like that. It performs differently versus, in a cold environment versus a warm environment and things like that. That these are things we're all learning. And then on top of that, it seems there's a big influx of new admixtures too. And so we're throwing that in the mix. So on top of just trying to figure out a plain, just regular concrete with the new cement in it, we're throwing chemicals and all kinds of new stuff in it. And some guys are finding success and others are just chasing their tail trying to figure it out. Because bottom line is, when we put the concrete down, we want a nice quality finish, and we don't want to be standing there for 2 days as it cures either. So that's spoken as the guy installing it, as opposed to the guy owning it. That's right. So that's what we're going through right now. But
but it's been known for a substantial amount of time that the lower or the more mitigated and metered out the heat of evolution and time to set and keeping it well hydrated gives you a much more durable structure.
Right.
Because you get away from the micro cracking that happens from the high thermal excursion. And so that's been known for a long time. But day one drivability that some people want, it's diametrically opposed to durability. And, so, and I think most people don't realize how important it is to mitigate as much microcracking in the early stages of cement, because that's your prelude to bigger cracks later on. Yeah. And so I feel the pain on both sides. The side doing the installation, they're following rules. They want to finish the project and move on. But I also side a little bit more with the owners that have to maintain the structures, because once a freeway or an overpass or a bridge goes into operation, people's lives are now engaged.
Yeah. Well, yeah. Push back a little bit. So DOT and those folks, I understand that. And you could probably, I don't know their maintenance program, but I know just through my career building different things, parking garages mainly, that owners don't maintain their product, and they want it done fast. They don't want to wait around. They want to hear any excuses why things take longer to build because we're using the new cement.
They can't charge until it's there.
That's right. And the concrete guy makes money the quicker he puts it down. But to go to your point about the quality of it, and doing the curing is what you're inferring to the right way. Hopefully you do it right the first time. You don't have to go back, because we do a lot of that too. We put it down and then we go back and fix things, which we're really good at that.
Well, the building industry is plagued by callbacks, and that's where you lose all your money.
Yeah.
So you don't want to have a callbacks, but sometimes, to your point, it takes too long to do it to the nth degree.
Well, if everyone's on the same page and understands that hey, this is the new process, this is huge. How it's then if everybody's on board, that say, hey, instead of for instance, if you're doing a multi-level post-tensioning deck and we like to pull PT the next day, if everyone understands now maybe it's 3 days, maybe it's 7 days before you get on there, full PT, and the concrete's going to perform better in doing it in that fashion.
Yeah, but those are agreements you need up front, because, I don't think it's malicious intent that people want to finish things quickly. I think it's a highly desirable component in how we live. But sometimes I don't think people appreciate the downside of doing that sometimes. And, just because something didn't fall apart in the first 10 or 15 years, well, if it's supposed to last 70 years,
Yeah. Like our infrastructure issues that we're having right now.
Yeah, we got a 1950s, 1960s infrastructure, and we want everything to work perfectly. We got 1,700 dams that need replacement or restoration. We got 42% of all of our bridges in the United States are past their useful lifetime, or the estimated lifetime when they were built. And, the American Civil Engineering Association puts out a report card every couple of years, and we're kind of at a D+ for infrastructure.
Mm-hmm.
And their estimate back in 2017 was that we'd need $3.5 trillion just to do all the maintenance on our buildings. And so, 10.3 by 2040. And when you look at that and you see Congress patting themselves in the back for passing a 1.2, there's a disconnect about how expensive it is to replace, structures that are critical.
Yeah.
And then we're surprised when things fall down. And I don't think the concrete and engineering groups are, but I think everybody else is.
Yeah. Yeah. Is there any other programs or anything else with the DOE you want to share with us today?
Right. Oh, the other one that you might look into that does a bigger is EERE. That's the Energy Efficiency and Renewable Energy. They're a much larger group too, and they have a number of programs that they come up with related to cements and concretes, and their funding is ARPA-E tends to be in the 1.8 to about $5 million on an average for funding individual projects, and EERE can be substantially more than that. We do have something called Scale Up for projects we've funded in the past, and those can be as high as 10 or 15 million. But you have to have gone through the original funding proposition through ARPA-E before you can qualify for that. But Department of Transportation is getting heavy into cements and concrete studies right now too.
Yeah.
So I would track their site as a potential area, and of course they're doing large structures, and so they must fund prototype projects that are probably north of 10 million, I guess.
Yeah. Other than the CO2 puzzle that we're trying to figure, is there any other, like we were talking before, any other challenges out there that the DOE has put out that comes to mind?
Right. Besides the what I called cement program, there's another one using waste energy and waste materials as SEMs too. That's a colleague of mine, Doug Wicks, put that together, and a lot of the big waste management groups or Browns Ferry and all these really want to figure out a way, because waste materials just keep accumulating. You can't keep landfilling them. So can you valorize them some way, and burning them for their energy content and then taking the ash and using that as a value-added material is one of the ways they're looking at it. They're also looking at it as a way of concentrating critical elements for a lot of the other components that people use in electronics, magnets and things like that.
Yeah. I just read something and I shared on a newsletter I sent out to my subscribers about the amount of tires we produce every year and the amount that go in the landfill and the some that we burn as well.
Mm-hmm.
The amount of that is just mind-boggling. Like you could literally stack the tires on top of each other and go to the moon. The amount of tires that are out there.
Well, you might remember that Jacques Cousteau wanted to build islands out of used tires.
I don't recall that.
Yeah,
Did he really?
He wanted to build reefs and tires because they're among the most durable things on the planet.
Yeah, they last. It takes, 50 plus years for them to degrade?
And even then, there's still something left. They're a very tough cross-linked polymeric system. They're black because you put carbon black in it. But, they're hard to recycle because there's this dog's dinner of chemicals, plus, steel belts and nylon threads. And you can't disaggregating and just grinding them up. Sometimes people use them in asphaltic applications, so in asphalts.
Yep.
But
that's where they chew them up, and then you see them at the playground as the so the kids bounce off the ground when they fall down.
Yeah, unlike us, we just hit the hard concrete.
Right. Yeah. So what's occupying most of your time now since you're not at the DOE?
Well, since I started in Golden Bear, a number of groups have used me as a consultant on cements and concretes, but they also want to make sea barriers it's one of these things. I was on the Department of Defense's review committees for refence, which is making reefs to stabilize offshore. And whether or not you believe in global warming, erosion is as huge a problem as the rising sea. So can you do these barrier things to help mitigate the impact of storms on both the stability of the land and protection of the people? And so I'm looking into marine concretes a lot more right now. So it has a secondary thing is it has to be biocompatible with the environment. You can't just have it there. You want little sea creatures to embed themselves on it and make it a natural material after.
Yeah.
So you become the base, and then the accretion from all the little creatures become the big barrier over time. And then it's alive.
So what's the status of that project? Are you guys still thinking of what that recipe looks like? Or
Well, the Department of Defense has already moved on and is doing a lot of testing protocols out there. I'm not engaged in that beyond.
Okay.
So I don't know the state of those projects other than they should be more than a year into it now. The one that I'm doing up off Long Island is just getting started.
Okay.
So ask me in a year. How's it going?
We'll get you back on the podcast and talk about it. Well, Joe, I think there's a good spot to stop today. If folks want to reach out to you, what's the best way?
Well, the easiest way is probably an email, and it's just my name, josephakingjr @gmail.com. So it's josephakingjr @gmail.com.
Cool. Yep, and we'll put that in the show notes so everyone can reach out to Joe. Joe, I appreciate you coming on the podcast. And just to share, this is my first live in the studio podcast with legit gear. So, Joe, thanks for coming.
Well, thank you very much for inviting me.
All right. And that concludes another episode of the Concrete Logic Podcast. I hope you got some value out of that episode and learned a thing or two. If you did, visit our website, concretelogicpodcast.com. Click on the Show Support tab and learn how you could be listed as a producer of an episode. Again, that's concretelogicpodcast.com. Click on Show Support tab to learn how you can support the show. And as always, Mike Dunton will take us out.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're out here changing these skylines with wood, iron, and mud. We work hard for a dollar, give thanks to the Lord above. Never make a man do something you can't prove. Hard work calls for a drink or two. Expect more, it's written in our blood. With wood, iron, and mud. From the swamps to the city, from the Lone Star heat to the woods of the Georgia pine. Good old boys and girls who ain't afraid of getting dirty for a clean time. And if you want to see the fire in a grown man's eyes beneath the hot summer sun, find the wild-eyed boys clocking days and nights, working hard to get that job done with wood,